Okay, so this is 4.7, number 5. Statement S is that the reciprocal of any irrational number is irrational. And we're supposed to write the contrapositive of this statement. But in order to write the contrapositive, it's really helpful if we can first rephrase the statement as an if-then. Okay, so if the reciprocal of any irrational number is irrational. So we want to say if a number is irrational, okay, then its reciprocal is irrational. So these two statements are equivalent. I just rewrote the first statement as an if-then. Okay, so this is also S. Okay, so the reciprocal of any irrational number is irrational is equivalent to saying if a number is irrational, then its reciprocal is irrational. And then the contrapositive is if Q, then P. So, sorry, that's the converse. The contrapositive is not Q implies not P. So if not Q, so if a number's reciprocal is rational, so that's not Q, okay, then not P, then the number is rational. Okay, now we want to prove the original statement by proving the contrapositive. Okay, so we're going to try to prove the contrapositive. And when you show that the contrapositive is true, we've proven the contrapositive, you've also proven the original statement because a statement and its contrapositive are logically equivalent. So, proving the contrapositive, we assume the if part of the contrapositive and prove the then part. Okay, so we have if a number's reciprocal is rational. So we're going to assume a number x has a rational reciprocal. That is 1 over x, because that's the reciprocal of x, is rational. The definition of rational is that the numerator and denominator are both integers, denominator non-zero. Okay, so by the definition of rational, x is an integer and x is not 0. Okay. Thus, x, which is the same thing as x over 1, is rational because x and 1 are both integers with the denominator not being 0. For part B of this question, we're supposed to negate S. Okay, so it says the reciprocal of any irrational number is irrational. The negation of this would be that there is at least one, that we can find one irrational number whose reciprocal is not irrational. Okay, so there is one or more, but one will do. There is one irrational number whose reciprocal is not irrational or rational. And then we're supposed to write a proof for S. We're trying to prove S by contradiction. Okay, so rather than using contrapositive, we're going to do a proof by contradiction. So in a proof by contradiction, you assume the opposite, right? So if I'm trying to prove S, I want to prove S is true. Let's suppose S is not true. Okay, suppose S is not true. Then that means there is an irrational number whose reciprocal is rational. Let's call this number that we are looking for, this irrational number whose reciprocal is rational, let's call this x. There's a irrational number x whose reciprocal is rational. Okay, so we've supposed that this number exists. Let's consider its reciprocal. Consider the reciprocal of x, 1 over x, okay, which is supposed to be rational. Okay, but the only way a number can be rational is if its numerator and denominator are both integers, denominator not 0, okay? 1 is an integer. Well, we know 1 is an integer, so we don't have to worry about the 1. Let's think about the x. Is x an integer? Can't be, because x is irrational, right? X is irrational, which means it cannot be an integer because all the integers are rational. Okay, so we'll say since x is irrational, x cannot be an integer, and thus 1 over x is not rational, cannot be rational. So we've reached our contradiction and we have proven S. Okay, thus S must be true.